All right, today we are jumping into a really fascinating scientific detective story. The case? Well, it's all about cracking a huge mystery behind Crohn's disease, a condition that, affects millions of people. We're going to follow the clues, follow the evidence, and track down a very specific culprit that's been hiding in plain sight, right inside our own immune systems.
So let's frame this whole investigation with one central question. What if everything we thought we knew about the cause of Crohn's was basically a big case of mistaken identity? What if the real bad guy, the true perpetrator, was just one highly aggressive cell hiding out among all of its look-alike, more innocent relatives?
And look, this isn't just some theory we're throwing around. Our whole story is grounded in some serious, real-world research. A paper from 2023, published in the Journal of Crohn's and Colitis, lays out all the evidence. It's like they were tracking a new lead in this super complex case, and it led them to point the finger at a player nobody had really characterized before.
Now, every good investigation has to start at the scene of the crime. And for us, that's the human gut, a place that, in this case, is in a constant state of turmoil and inflammation.
So what is Crohn's disease really? Well, it's this chronic condition where the body's own immune system just goes haywire and starts attacking the digestive tract. It causes incredibly painful, debilitating inflammation. And for the longest time, the specific driver, the thing that's actually kicking off this attack, has been a total mystery. It's been so frustrating for so many.
Okay, so let's line up the usual suspects. In pretty much any case involving an autoimmune disease, the first place the detectives look is at the immune system's enforcers, this group of cells we call T cells.
And within that group, there's one particular type of cell, the T17 cell, that has always been a prime suspect. Now, these cells are normally the good guys. They're like essential security guards. They produce this powerful alarm signal called IL-17 that calls in reinforcements to fight off certain infections. But when they get stuck in the on position, when they're chronically activated, that constant alarm blaring can cause a ton of collateral damage. And that right there is a hallmark of autoimmune disease.
But any good detective knows the usual suspect isn't always the one who did it. So researchers decided to look closer, to see if there was something different, something more specific about the 13 cells they were finding in Crohn's patients. And this is where the case takes a really interesting turn. Using this incredibly powerful technique called flow cytometry, which you can just think of it as a super high-tech machine that can sort millions of individual cells at lightning speed, scientists started sifting through the evidence. They were basically dusting for fingerprints, right? Looking for some unique marker that would separate a truly criminal cell from a law-abiding one.
And they found it. Bingo. A distinct subset of these Th17 cells that had been hiding in the crowd this whole time. For our story, we're going to call them pathogenic Th17 cells, or PTH17 for short. This was it, our new prime suspect.
So what's the big deal? What makes this P17 cell so different from a regular one? Well, this slide basically lays out the rap sheet. A normal T17 cell has one marker, CCR6. Our culprit has that one, plus a second one, CCR5. Think of it like a distinguishing tattoo that sets it apart. But here's the critical part. It's not just about how it looks. The P17 cell doesn't just produce that inflammatory signal, IL-17. It produces it in dangerously high amounts. And on top of that, it also fires off another powerful inflammatory molecule called IFN gamma. So it's basically walking around with a double-barreled weapon where its peers only have one.
And this chart, this is the smoking gun. I mean, just look at how much more inflammatory firepower these P17 cells are packing compared to the conventional ones. It's not even close. This is a cell that is literally supercharged for inflammation.
And get this, where did they find this highly armed suspect? Not just floating around anywhere. No, they found it in huge numbers, absolutely swarming the scene of the crime, the inflamed gut tissue of patients with Crohn's disease. And at the same time, it was pretty much absent in healthy tissue. This proves it was right at the heart of the attack.
But a good detective always knows that criminals rarely act alone. So the next big question was, what's setting these PH17 cells off? What's their trigger? Who is their accomplice?
So we've got our culprit. But what exactly is the thing that pushes these cells over the edge? What makes them go rogue and unleash their entire inflammatory arsenal on the gut? So the investigation uncovered a really clear chain of events. It all starts with a specific kind of bacteria called adherent invasive E. coli, or AIEC, which you often find in Crohn's patients. So when this AIEC shows up, other immune cells send out a very specific alert signal called IL-23. The Th17 cells are uniquely tuned to receive this IL-23 signal, which basically acts as the go code, causing them to light up and release that destructive storm of IL-17 and IFN gamma.
And if you want proof, here it is. The scientists tested this. When they exposed the Ph17 cells to a harmless, friendly probiotic, E. coli, you can see on the left, pretty much nothing happens. But when they exposed them to that Crohn's-linked AIEC strain, a massive, explosive reaction. This isn't a cell that just fires at anything. It is dangerously, specifically attuned to this one particular bacterial accomplice.
So the case seems solved, right? We've got our culprit, PTH17, and its accomplice, the AIEC bacteria. We even know the weapon, IL-17. The solution should be obvious. But this is where our detective story delivers its biggest and, frankly, most important twist.
I mean, the logic seems absolutely flawless. If IL-17 is the weapon causing all the damage, then the most direct way to treat this is to make a drug that blocks it, that neutralizes the threat. It's the perfect plan, isn't it?
Well, no, not so fast. A drug was actually developed to do exactly that. But as this study from the Journal of Crohn's and Colitis reports, it not only failed to work in Crohn's patients, it actually seemed to make the disease worse in some of them.
And that drug is called secukinumab. Its entire job, its whole purpose, is to block that IL-17A molecule. And it works wonders for other conditions like psoriasis. But in the unique battleground of the gut, the immune system's response was completely, totally paradoxical. Just let that sink in for a second. The very act of trying to shut down a key inflammatory weapon led to more inflammation. This just shows you the incredible and sometimes maddening complexity of our immune system. It is not a simple machine with on and off switches. It's this deeply interconnected network where if you block one path, you can unexpectedly force open another, even more dangerous one. It's like you plug one leaky pipe only to have the pressure build up and burst a giant water main somewhere else in the system.